If I give you an ionic compound, MgCl2, can you tell me what is the empirical formula and the molecular formula? Do we have a different molecular formula, or ionic compounds have only one formula, which is empirical formula? What do you think? It has only one formula, and that formula is empirical formula. There is no molecular formula for ionic compounds. Okay, good. And then we discussed this that for the covalent molecules, we have both the formulas. We have empirical formula and molecular formula. To know the molecular formula, we have to multiply empirical formula by a factor n. And this n factor is the molar mass of the molecular formula divided by empirical formula mass. So you get the n factor, multiply your empirical formula by that n factor to get the molecular formula. How to get the empirical formula? You make a table. So do you remember the columns of the table? First column is list of the elements. Second column is, yes, their masses. That information will be given to you as percent composition. Third column is moles. Yes, very good. Amodita, can you change your name? Fourth column is, yes, ratio. Akash. And then you have to convert that ratio into simplest, this is simplest whole number ratio. So we are going to use this table to calculate the empirical formula. Now we are on the questions in which we'll deal with molecules. Molecules means covalent molecules. And we'll make the table. Read this question. And let's start filling the table. So what are the elements here? We did this one, Mayank, in the last class. Okay. So elements are carbon, hydrogen, and oxygen. The percent is given, so you are going to assume the total mass. Total mass we are going to assume as total mass of the sample containing these three elements of that compound, 100 grams. So it means I know the mass of the carbon. This is mass. So 48.64. This is in grams now. Hydrogen 8.16. How much is oxygen? Oxygen is not given, but we know that the total is 100. So 51.2 grams. Okay. Get the moles. Moles of each element. So divide this by 12.01, 8.16, 1.01. This is hydrogen. It's not H2. It's H. And oxygen by 16.0. Okay. Akash is correcting me. Akash, you said 51.2. Now you're saying 43.2. Anyone confirming this? Can you confirm? Yeah, it should be less than. Yes, it cannot be 51. Okay, good, Akash. So it is 43.2. Be ready with your calculator. Today we are going to do questions based on calculations only. So what are the moles? Moles of carbon, Mayank is saying 4.05. Let's take up to 3 significant figures, or you can go more, 4 point, because this is where we can have error. So try to be more accurate. Hydrogen is 8.0792. Oxygen, how much is oxygen? Amodita, exactly 2.7. Pick up the smallest number. The smallest number is 2.7. Yeah, Amodita is giving me more accurate. Okay, let's take more accurate. Okay, now divide these moles, all the moles, by this smallest number. To get the simplest ratio, this is 1 here. Divide this by 2.7107. Divide this by 2.7017. What's the answer? For the first carbon. What's the answer for carbon? Oh, you're not giving me these answers here. Is this 1? What is this? And how come you're getting so many? Oh, 1.5. Okay. 1.5. The other one is 3. Okay. And then to make it the whole number ratio, multiply by 2. Then it is 3, 6, 2. So the formula is C3H6O2. So these questions can be there. So here the information is given as percent composition. In some cases, it will be given as in the form of a reaction. Like we'll do different types of questions. Now this is a different type of question. Ready for this? Make the table. Fill the table. Assume the total mass as 100. So carbon, hydrogen, chlorine. These are the elements. The masses are 47.08. This is in grams. 6.59, 46.33. Get the moles. Divide this by 12.01. This by 1.01. This by 35.45. Get the moles. Amodita, can you tell me the moles? Go to maximum significant figures. 3.92006. To minimize the error. 6.52475. 1.306911. Pick up the smallest number. I think this is the smallest number. So divide everything by this number and give me the ratio. I'm writing here, waiting for the ratio. Three, 5, 1. And Amodita has already given the formula. What is this, Amodita? Is it an empirical formula or the molecular formula? This is? No, Akash, this is empirical formula. You're taking the ratio, simplest ratio. So I just calculated the empirical formula. Amodita, this is the empirical formula. They're asking molecular formula also. So we answered this part of the question. This part is answered that the empirical formula is C3H5Cl. It's a ratio, right? Simplest ratio, Akash. You missed the class, watch the video. So the molecular formula is Now to get the molecular formula, molar mass is given 153. Get the N factor. N factor, N is the molar mass divided by empirical formula mass. Yes, it is 153 divided by empirical formula. Are you getting 76.5 as the? Yes, I'm also getting the same. Divide this. Here, Amodita. The molar mass of the compound is, check. Now Akash is saying this ratio is 2. Now take the empirical formula. Empirical formula, then as a subscript right here, N is the molecular formula. So what is the empirical formula here? C3H5Cl, then take 2 here. So the formula is, yes Akash, very good. Where are you, Mayank? H10Cl2. Mayank, you're understanding? Okay. That's the molecular formula. In this question also, all the information is given as percent. Questions will be twisted very soon. You have to get this information, the elements and the masses. Only then you can work out the empirical formula. Now the question gives you this information in terms of straight away they can give you the masses, or the way they are giving you information here as percent. But in some questions, they will give you information indirectly as the product of the reaction, amount of the product. So we are going to do those questions now. Okay, this is also a good question. So read the question very carefully and tell me what all is given and complete this table. So we are working out the empirical formula, which will be very easy. Elements are carbon, hydrogen, oxygen. And their masses are, I'm going to assume the total sample is 100 grams. This malic acid, total sample. If you don't write this, that's fine, no problem. Total sample is 100 gram. So it is 41.39, 3.47. This is in grams, right? So write the units here. When you are, if it is a free response questions, be careful, write the units, every unit. So you can put it in the top here, and then there is no need of writing grams every time. How much is oxygen, children? How much is oxygen? I'm getting 55.14. Very good. 55.14. Now divide this by 16. It will give you the moles of the oxygen. I'm getting 3.44625. Divide 3.47 by 1.01. Get the moles, Mayank. Get the moles. Carbon, get the moles of carbon, divide by its atomic mass. We are dividing it by atomic mass. Yes, ma'am, good. And carbon, 3.4462. Which number is the smallest? This one? I think they are very close. So what's the ratio? 1 is to 1 is to 1. Very good, Amodita, very fast. So what's the empirical formula? CHO. What's the empirical formula, mass? 12 plus 1, 29.02, okay. Grams, right? Per mole. Empirical formula mass, grams per mole. That's the unit. Now, what's the molar mass? Is the molar mass given to us because they are asking molecular formula? Is molar mass given to us? So read this information. If 0.129 moles of malic acid has a mass of 15 grams, what is the unit of molar mass? Molar mass is grams per mole. Very good, Akash. And here the grams is given to me as 15.0. Moles are given to me as 0.129. This will give me grams per mole. 0.129 has 15 grams. So 1 mole has how many grams? And how much you are getting molar mass? 116.279. Okay, is it correct? Amodita, is it correct? Amodita and Meng, check what Akash is giving me. I'm using this calculation. Now get the N factor. N. So molar mass is 116.279 divided by 29.02. What is N? N is 4. You can take it 4, right? N is 4. Yes. So what's the molecular formula? So you take your empirical formula, CHO. Okay, so CHO and then N factor, which is 4. So the molecular formula, yes, C4H4O4. Very good, my Akash. So this is another type of question. Here molar mass is not given. So understand that question will not be always the way I'm giving you here. They may twist the question. So you have to understand that, okay, if the question is there, my first aim is to know the elements. My second aim is to know their masses. If I know the elements and the masses, I can work out the empirical formula. But if they're asking molecular formula, then I need to know the molar mass. So in the question, how the information is given, derive all these things. So ready for another question? Okay. This is the question here. Information is in a different way. This is also called as combustion analysis. In this case, you have taken this ethanol. You are doing combustion, in combustion of ethanol means ethanol is reacting with O2. No, aim is to get the formula of ethanol. We are working to calculate the empirical formula and the molecular formula of ethanol. Ethanol plus O2 is giving you CO2 and H2O. Even I don't know the balance equation, I know the products. So how many grams of CO2? And they have given me the information that ethanol has carbon, hydrogen and oxygen. Ethanol has carbon, hydrogen and oxygen. But these masses are not given to me. What is given? Grams. If it has only carbon, hydrogen, oxygen, then all the carbon is here and all the hydrogen is here. But oxygen, I cannot say because oxygen is coming from combustion also from outside, right? So we are not going to work with oxygen at all, Akash, because oxygen is not just because of the ethanol oxygen. Oxygen is coming from outside. I'm using excess of oxygen from air. And then ethanol is undergoing combustion. Here we have a material So you can measure the mass of water. You can measure the mass of CO2. You have the mass of ethanol also. These are the things given to me. So what I'm going to do? So carbon and hydrogen of the CO2 and water has come definitely from ethanol, right? So we are going to, but still we are not going to work with oxygen because oxygen is in ethanol and oxygen is here also. So this oxygen is not only in ethanol. Please understand this, right? So don't work with oxygen. So what we are going to do? We are going to start with grams of CO2. We'll convert that into moles of CO2 because carbon is only from ethanol. So we'll work with that. Moles of CO2 to moles of carbon and fill in here. Similarly, hydrogen is also coming from ethanol. So I'll work from grams of water to moles of water and to moles of hydrogen. And I can fill here. But now I need to know oxygen of ethanol. Not this oxygen, not this one. I need to know oxygen of ethanol. So what I'm going to do, I'll convert my moles of carbon to grams of carbon, moles of hydrogen to grams of hydrogen. Then to know the grams of oxygen in ethanol, I will take the mass of ethanol, which is 11.5 gram, minus grams of carbon, which I calculated here, plus grams of hydrogen, isn't it? So plug in the grams of carbon here, grams of hydrogen here, and these two masses subtracted from the total mass of the ethanol. And I want you to listen very carefully, Akash. Answer, I'm not looking at the answer right now, okay? You are going to give me dimensional in one go, all the answer in one go. Then you work out the oxygen amount, get the moles, moles of carbon, you are already here. Moles of hydrogen, you are here. Then get the moles of oxygen, ratio, and empirical formula. Now, we are going to do this question in dimensional form, in one go. Okay, so start with 22.0 grams of CO2. Give me the first ratio, the second ratio, the third ratio, the fourth ratio. This is the planning. So 1 mole of CO2 divided by 44 grams of CO2. That's the molar mass of CO2 times. Now what is this ratio? Tell me this ratio. I want to go from moles of CO2 to moles of carbon. In 1 mole of CO2, how many moles of carbon are there? Yes? Yes, 1. Plug in that ratio. 1 mole of carbon over 1 mole of CO2. Yes. Give me the okay, stop here. Do the calculation. I think I've taken one extra ratio here. I'm going to erase it. Stop here and get the moles of carbon. Because I need to know moles of carbon, right? How many? 0.5. Plug in here. Now let's work for hydrogen. Now we are working for hydrogen. Same method. Start with grams of water. 13.5 grams of H2O. Plug in the first ratio to know the moles of water. 1 mole of water divided by 18.02 grams of water. Plug in the next ratio to know the moles of carbon or moles of hydrogen. Yeah, what is the ratio here? Give me this molar ratio. Moles of water to moles of hydrogen. Yes, 2 moles of hydrogen over 1 mole of water. Stop here. We need one more ratio later on. Stop here first. Get the moles of hydrogen. 1.5, I think. Not sure. Yeah, 1.5. Okay. Now get the grams of carbon. I need grams of carbon and grams of hydrogen to know the grams of oxygen, right? So plug in another ratio here in the same dimensional. So 12.01 gram of carbon over 1 mole of carbon. So grams of carbon are, writing here children, 6.005. How many grams of hydrogen? Get the grams of hydrogen. Just plug in another ratio. This 1.5 multiplied by 1.01 gram over 1 mole of hydrogen. And remember, sometimes the students, they plug in the molar mass of H2. It's not H2. We are dealing with hydrogen atom. So Mayank is saying 1.515 grams. So how much is oxygen? Use this equation. You have the total mass of the ethanol. So subtract the mass of carbon and hydrogen from ethanol. How much? Okay, so Akash is saying 3.98. Convert that into moles. Okay, 0.25 moles. Pick up this smallest number. Get the ratio. 2 is to 6 is to 1. Pick up this number and divide all of them by this. So the formula is C2H6O. Now, in the question, they have given the molar mass. Molar mass as, yes, Mayank, molar mass is given as 46.06 grams per mole. Get the molecular formula now. You have the empirical formula. So, N factor is 46.06. And if you calculate the molar mass, empirical formula mass is going to be the same. So, answer is 1. So, in this case, empirical formula and the molecular formulas are same. So, here the information is given in the form of combustion analysis. This is an experimental condition. It's a lab kind of question, lab based. You're burning the compound. Children, are you clear that why I have not started my question with oxygen? Akash, is it clear? Because oxygen is used in excess. And oxygen is coming from outside. It's not the part of only ethanol. So whatever oxygen is here in CO2 and H2O is also from excess of the oxygen. So that's why we are not going to start with oxygen. We'll start with carbon and hydrogen, which are entirely coming from the ethanol. And then we can subtract it from the total mass of the ethanol. This question is clear? Moving on. So this we have done. Ready for this question now? Now you are my smart students, so I'm going to give you one formula here. And practice it. School teachers will not give you practice on that because school teachers, they are just don't want to create confusion because they are dealing with big groups, so they don't want to give the confusion. So practice this formula. We can practice it. You know that molar mass has a unit of grams per mole. Whatever is the molar mass in grams per mole, exactly same will be there in milligrams per millimole. Like for water, the molar mass of water is 18.02 grams per mole. If I want to express that milligram per millimole, answer will be the same. Because you know that 1 milligram is 10 raised to power minus 3 grams. And you know that 1 mole is 1 millimole. 1 millimole is 10 raised to power minus 3 moles. If I give you moles per gram, if I ask you to convert this into millimoles, then can I write it like this? 10 raised to power 3 millimoles divided by 10 raised to power 3 milligrams. Can I write like this? Then this cancelled. Factor is same. Either you write it like this, you know, SI units, their prefixes. I can write from here that 1 gram is 10 raised to power 3 milligrams. Can I say that? They have the same meaning. Here also I can say 1 mole is 10 raised to power 3 millimoles. So the factor in the numerator and the denominator is same. So that is the reason I'm saying whatever mass is there as grams per mole, exactly same mass can be there as milligrams per millimole. So if some question, like in this question, everything is given to me in milligrams, I'm not going to convert this into grams. I'll use it as such. Only thing that I have to take my molar mass in milligrams per millimole. So here, I'm not going to convert milligram to gram. I will work with milligrams and millimoles. Are you okay with that? Milligrams and millimoles. Because if I convert this into grams, then it becomes 16.01 times 10 raised to power minus 3 grams. But I will tell you, your teacher is going to convert. But let's practice in a different manner. We are comfortable with this? Okay, ready for the question? A compound contains only carbon, hydrogen, and oxygen. So elements are given. So I'm listing the elements here. Carbon, hydrogen, and oxygen. 3 elements. Okay. The total mass of the sample is given. Total mass. So mass of sample means the one on which you are doing this combustion analysis. You are burning it. Combustion. Combustion means one of the reactant is oxygen. Excess of oxygen. So I need to know mass of carbon. I'll work with milligrams. I'll work with millimoles. So 16.01 milligrams of CO2. I'll convert this into millimoles of CO2. Then to millimoles of carbon. And I'll stop here and plug in here. And then I have to convert this into milligrams of carbon because there is no information about oxygen. I have to derive the information for oxygen. You can see here this carbon is coming from the compound. This hydrogen is coming from the compound. But the oxygen is coming from the compound as well as by combustion, by air. So I have to work out the oxygen of the compound by using this mass. So mass of oxygen is 10.68 milligrams minus milligrams of carbon plus milligrams of hydrogen. So ready? Let's do it. You need not to do any changes. The molar mass stays the same. 16.01 milligrams CO2. Plug in the first ratio to know the millimoles of CO2. Yes, who is going to tell me the ratio? Molar mass, whatever you are taking from the periodic table, if you write it in milligrams, then it is for millimole. If you take it in grams, then it is for mole. How much? What is the first ratio, children? Amodita, first ratio. 1 millimole of CO2 divided by 44.01 milligrams of CO2. 44, Mayank? I think it's 0.01, yes. What is the next ratio? Write the next ratio. Amodita, ratio. Millimole of CO2 to millimole of carbon. 1 millimole of CO2 has how many? Amodita. 1 millimole of CO2 has how many millimoles of carbon? 1. So 1 millimole, that's why I'm asking you to go step by step with me. 1 millimole of CO2. Stop here, get the answer and plug in here. We are learning how to do question as a free response also. So during the class, I will be doing only free response. Most of the questions will be free response. 0.3638. These are the millimoles of carbon. Now convert these millimoles into milligrams. So 12.01. Now I'm going to take milligrams over 1 millimole of carbon. So when you are working with millimoles, work with milligrams. And no change. Same atomic masses, same molar masses. Right? How much you are getting? You are getting milligrams of carbon as 4.3690. Ready for hydrogen now? Start with whatever amount of water is given. 4.37 milligrams of CO2. Plug in the first ratio, plug in the second ratio, and third. Stop here, get the millimoles, plug in here. Then get the milligrams. Plug in here, milligrams. Then get the oxygen. Ready? Okay, not CO2, sorry. We are working with water. Water, H2. Okay. So what's the first ratio? Can you type here the ratio? I just want you to be very comfortable with millimoles and milligram. What are the units, Mayank? 1 millimole of H2O is 18.02 milligrams. Yes, Mayank, good. Next, Amodita is saying 2 millimoles of hydrogen over 1 millimole of water, dimensional. See, the units are cancelling. Get the millimoles of hydrogen. Yes, Akash, no problem. I hope you are getting comfortable with the millimoles. because we are going to work with millimoles, then we are going to work with milliliters, then I'm going to calculate molarity as millimoles over milliliter as we go for the next unit. So just that's the reason I'm asking you to practice in terms of millimoles also. School teachers will not do it. So don't get confused there. So how many millimoles of hydrogen? Anyone calculated? I calculated. How come I'm faster than you? I'm teaching also and I'm calculating also. Mayank, I'm faster than you, Mayank. Okay, what is this? Milligrams? 485016 milligrams. So how many milligrams of 85? I'm not getting this answer. I'm getting, oh, these are the millimoles. Milligram is 48019. Amodita is saying the milligrams of oxygen are 5.801. Get the millimoles, Amodita. If it is correct, this is correct, children. This one. Mayank, is it correct? I have just taken the value given by Amodita, assuming that she is correct. Okay, yeah, Mayank, understood. But is oxygen correct? That's my question. Okay, fine. So small error in the calculations. Okay, 5.82. That's fine. So how many millimoles of oxygen? So children, I'm not interested in final answer. I'm working with you step by step. So please don't try to put final answer in one go. 0.3637. So this number is nearly same. So this is 1 and this is also 1, right? How much is for hydrogen? What's the ratio? You divide by this number. Work out the ratio for hydrogen. This is 1.3. Hydrogen is 1.3. So I think it's better to multiply everything by 3. And then you get, this is 3, this is 3.9, which is taken as 4. And this is 3. Understand, children, if it is 3.9, you can make it 4. But if it is 3.8, do not approximate. Okay, 3.8 cannot be taken as 4. That is the reason I'm asking you to very, very accurate here. So that you get very accurate number and you can easily convert your ratio into the right whole number. If it is 3.8, you cannot make it 4. Understand that. Okay. So now the formula is C3H4O3. What is this? Empirical formula. Now I need to know N factor. The molar mass is given. This molar mass, I can take it in milligrams or grams. That's fine because we are done with the empirical formula. So what's the empirical formula mass? You can calculate it in grams per mole. Are you getting 88.07? Okay. Grams per mole. Get the N factor. Akash, N factor. Amodita. N is 2. 176.1 over 88.07. So N is 2. N has no units. It's a number. It's the ratio of grams per mole. Grams per mole cancelled. Molar mass is grams per mole. It's a number. No units. So empirical formula is this. So multiply this by this factor N as a subscript C6H8O6. Is this given by you earlier? Uh, Akash? No, right? That is the reason, Akash, I'm asking you to go step by step. Work with me. Amodita? Amodita, are you there? Yes. You're comfortable? Okay, so here the information is given in milligrams. So some teachers, not some, all the teachers will convert this into grams. As I told you the reason why. Because sometimes it's very difficult to teach a group of 30, 40 children. So they just go for the easiest way. But I want you to work with milligrams also. Ready for this? And I think this is the last question on empirical formula and molecular formula. Oh, there are more. Let's go very fast. You people are reading the question, and here the information is given in the form of grams, and it's a combustion. You can see carbon, hydrogen, oxygen. I'm making the table. Carbon, hydrogen, oxygen. It's a combustion analysis. The mass of the fructose is given to us 1.50 grams. The sample is not the molar mass sample, and it has 2.20 grams of CO2, which you have to convert into moles of carbon and then grams of carbon. You have 0.900 grams of water. You have to convert that into moles of hydrogen and then grams of hydrogen. Then you have to calculate grams of oxygen by using the mass of the sample minus grams of carbon plus grams of hydrogen. And then you have to complete the table. Okay, who's going to tell me the moles of carbon and hydrogen first? I'm not working mathematics here with you. So tell me the moles of carbon and moles of hydrogen. Moles of carbon and mass of carbon. Let's fill this table first. Amodita, moles of carbon and mass of carbon. No, no, no. I'm asking moles of carbon and grams of carbon. Final answer. Not the formula. I'm asking this. I'm making the table. Yes, moles of carbon are 0.05. Get the grams also, Akash. How many grams? Just multiply it by 12.01. 0.6005. Similarly, do for hydrogen. Amodita, Mayank, are you getting this? Is there any error in my calculations? Are we on the same page? Okay, good. Get the ratio, the smallest number. This is nearly 0.05, right? So this is the smallest number. You divide, get the ratio, children. Divide everything by this number. You take it as 0.05. You will get 1 here. What's the ratio? 1 here. And you'll get 2 here. Yes. What's the empirical formula? What's the molecular formula? Molar mass is given. Molecular formula? So N factor is the molar mass, which is 180.0 grams per mole, divided by empirical formula mass, which is, I think, is 30 grams per mole. Answer is 6. So the fructose molecular formula is, this is fructose, is C6H12O6. Yes, Akash, it is the formula of the glucose also and the fructose also. Glucose, the one has aldehyde as the functional group, aldehyde. Fructose, the same formula, same number, everything is same, but it is a ketone. So generally, we call them as ketoses. This is aldose. Ose means sugar unit with aldehyde, and this is with ketone. Ketone, aldehydes, you don't know. Okay, these are the functional groups of the organic chemistry. So this is the difference here. Formula is same. Their functional groups are different. Okay, children. Ready for next question, or shall we go for some different type of questions now? So these questions you can do it as homework. Same type of questions. This time it's not oxygen, it's nitrogen. Same question here also. These are the combustion analysis question. Do you want to do these? I don't think we can do more questions. So I'm planning to move to do a different concept now. Can I give you these questions as homework? Yes, Akash, you have to leave in 5 minutes. So take these home questions as homework. Okay, I'm just placing these questions in the chat. One question is this. And I want the answer before the next class. And you can do the quiz also from the website. Another question is this. Now I'm taking you on the next important concept, that is Gay-Lussac's law, or we can call it as law of combining volumes. Or is also called as Avogadro's hypothesis. Now, what is Gay-Lussac's law or Avogadro's? The meaning is the same. Okay, so in this, when we are dealing with the gases, the number of molecules which are interacting here, like how many molecule of hydrogen gas is here? 1. How many of chlorine? 1. How many molecules of hydrogen chloride gas is formed? 2. The molecules of the gases combining can be taken as the ratio of their volumes. If all the gases, H2, Cl2, HCl, if they all are at same temperature and pressure. Condition is this. Temperature and pressure of all the gases is same. And generally, when we carry out a chemical reaction, temperature, pressure is same because they are in the same environment. These gases are in the same environment. So whenever there is a chemical reaction in which you are dealing with the gases, the molecules, the number of molecules can be counted, can be taken as the ratio of the volume. So I can say 1 volume of H2 reacting with 1 volume of Cl2 giving me 2 volumes of HCl. Can I say that? See here, the volumes are same. And because it is 2, so volume is doubled. Okay, here is a question. If I say there is 10 liters of H2, can you tell me how many liters of Cl2 are needed to react with 10 liters of H2? 10. How much hydrochloric acid is formed? How much volume? 20. And remember, some students, they get confused. They try to apply the law of conservation of volume. That is not correct. There is no law of conservation of volume. Nothing like that. Like for example, here, 2 molecules, 1, 2. So what's the ratio of the volume? 2 volume of H2, 1 volume of O2, giving you 2 volumes of water. If I give you 40 liters of H2 gas, can you tell me how many liters of oxygen needed? How many liters? Very good, 20 liters. How much water formed? 40 liters. Mayank, that's what I'm saying. Don't add volumes. Check the ratio. 2 volume formed. 2 volume is 40 liters. Mayank, this is 2 volume, 40 liters. Right? So you're not going to add 40 plus 20. There is no law of conservation of volume. These volumes are the ratio of the moles of molecules in the balanced equation. Are we clear about it? Children, when these people are working, these Gay-Lussac and Avogadros and Dalton, when these people were working at that time, they were not aware of electrons, protons, there was no electricity. So all the formulas, everything they derived based on measurement of volumes and measurement of masses. Yes, if the number of molecules are same, then volumes are same. Like here. Mayank, you have understood your error? If I give you this equation, they all are gases. This is applied only for gases. Do not apply it on liquids and solids. Yes, Akash, no problem. N2 plus 3H2 gas giving you 2NH3 gas. Now here, this N2 gases, if I take 1 volume, then how many hydrogen is needed, Mayank? How much volume of hydrogen needed? If this is 1, 3 volume. And how much of ammonia? Is 2 volume. So can I say 1 volume plus 3 volume? Is it 4 volume? Mayank, is it 4 volume? No. So there is no law of conservation of volume. Okay. So if I give you this as 10 liters, then how much hydrogen is needed? 30 liters. How much ammonia will form? 20 liters. Here I'm going to teach you one more concept, which is a very big concept. Very soon it will be coming up. Now, let's say I have given you 1 liter of N2 and 4 liters of H2. Can you tell me, by looking at this ratio, can you tell me how much liter of ammonia will form? and which reactant is left in excess. So you can see that, yes, Mayank, it is H2, not H. You're right. This is extra amount. How much is needed? Only 3. How much I have given? 4. How much is left? How much of H2 is left as excess reactant? 1 liter. And how much ammonia is formed? 2 liters. From where you calculated? From this 4 liter or from this 1 liter? Which number you have used for calculation? This 1 liter. You are not calculating for 4 because it is excess. It's not reacting completely. And how much N2 is left? How much N2 is left? 0. The reactant which is going to stop the reaction, because once it has become 0, reaction will stop. So the reactant which has become 0 and has stopped the reaction is the limiting reactant. So what is N2? N2 is the limiting reactant. It has limited the product. There is no more formation of the product once your limiting reactant has become 0. Hydrogen is excess reactant. So these type of questions can be there. This is a very separate topic, but I have just given you the introduction. So we'll practice more as more questions will come. Okay, so that's your question. So here, this is the definition. So according to this definition, if the gases of a chemical reactions are at the same temperature and pressure, you can see here, same temperature and pressure, then they will combine, their volumes will be in the same ratio as the number of molecules of the balanced equation. See H2 combining with O2. Can you write down the balanced equation by looking at these volumes? What is the balanced equation? Can we write down? 2H2, this is 1, O2, this is 2. This is the balanced equation. So just looking at the ratio of the volumes, I can write down the balanced equation. That's how these scientists, when they were not aware of electricity or anything, they were not aware of formulas. This is how they worked, the formulas and the balanced equations. Okay, ready for question now? Can we do this, Mayank? This is 2 moles. These balloons are at the same temperature and pressure. Same temperature and pressure. So this is the ratio of the moles and liters. 3 moles is 30 liters from this balloon. I can use this Avogadro's or Gay-Lussac's law here. So if this is, what is Avogadro's hypothesis? That's, I'm going to give you the definition here. Equal moles have equal volumes. These are only for gases, equal volumes at the same temperature and pressure. So 3 moles have 30 liters. So 2 moles will have how many liters? Can you work out this? Yes, that's the answer. Very good, Mayank. So this is 20 liters. Can you work out this? Yes, this is 4.5 liters. Perfect. And this is your Avogadro's hypothesis. Like if I give you this reaction, H2 gas, it's a gas here, reacting with another gas, F2, giving you 2HF gas. If I have taken 10 molecules of H2 and the volume of these 10 molecules is, let's say, 10, okay, I'm just changing the molecules to moles. Let's say the volume is 10 liters. And if I give you the volume of F2 as 20 liters, can you tell me how many moles of F2 will be there? 20 moles. And if I give you this as 40 liters, oh no, I'm going to give you this as 20 liters, this one. So how many moles of HF is formed? This is also 20 liters. So 10 moles is 10 liter. So 20 liter will be 20 moles, isn't it? 20 liters will be 20 moles. Agreed, Mayank? Okay. So now which reactant is the limiting reactant and which reactant is in excess? Can you identify? So you can work like this. 10 moles, this is 1:1, right? 10 moles will react with 10 F2, but I have given you 20. So yes, F2 is in excess. How much is left unused? Because out of 20, 10 will be used. Yes, 10 liters will be left in excess. How many moles left? 10 moles will be left in excess. 10 liters volume will be left in excess. What will happen to H2? H2 will become 0. What happens to HF? How much HF is formed? That you are going to decide from H2 only, because this is the limiting reactant. So king of the calculation is always the limiting reactant. Amodita, you are back? Limiting reactant. Okay. So limiting reactant will tell you how many moles or how much volume of HF is formed. Ready for next question? Okay. Amodita, are you there? Okay, read the question carefully, Mayank. Okay. So is it 1 liter of chlorine? Chlorine formula is Cl2. They are saying 1 liter. I'm writing 1 liter here. Reacting with 5 liters of fluorine. The fluorine formula is F2. 1:5. What's the ratio? If this is 1, this should be 5 in the balanced equation, giving you 2 liters of the product. 2 liters of the product. Product has chlorine and fluorine. So I don't know the formula. So first I will write chlorine, Cl, and then fluorine. I don't know X and Y, right? That I have to work out. But I know that the ratio of the volume is 1:5. So it means ratio of the molecule is 1:5. So how many chlorines are here? 2. How many fluorines are here? 2. Not 2, 10. So this is 2 here because they are saying 2 liters. So this product is with 2 coefficient in front. So how many fluorines? 10. So what should be Y? So that you have 10 fluorines. Yes. And Cl is, what should be X? You have only 2 chlorines. What should be X? 1. Yes. So what's the formula of the compound? ClF5. That's the compound formula. Chlorine in which form? It can exist as Cl2, not as Cl. You remember I told you it has to be Cl2, yes. Only your noble gases, they exist as monoatomic. What are the 5 diatomic gases? Remember diatomic gases? Come on, dear. This is a compound. It's not pure chlorine atom. Here Cl is not existing as Cl. It's existing chemically bonded with 5 fluorines. You are going to do the Lewis dot structure of this molecule. It's a molecule. It's stable, reactive but stable. It's not chlorine atom, right? So this is how these people, they worked out the formulas just from the volumes. Ready for next question? This is very simple. So you already know the reaction. H2 reacting with Cl2, they all are gases. The product formula is given. Can you balance the equation? Because here everything is given. So balance the equation. So when you balance the equation, you have 2 here. If we are using equal volumes, 1 volume of this, 1 volume of this, how much volume of HCl is formed? Mayank, you're wrong. Check it again. 1 volume of hydrogen. See this coefficient, Mayank? This coefficient will tell you the volume ratio, right? That's the law. That's what we are learning. So it will be 2 volumes of HCl. Mayank, is it clear? What are you learning? You are learning that in a balanced equation, the ratio of the moles is the ratio of their volumes. If I say this is 1 volume, this is 1 volume, now this is 2. So it should be 2 volumes, right? Okay. Now my next question based on the same question, same equation. H2 has its own properties, chemical properties. Cl2, it has its different properties. Do you think HCl is going to have properties similar to H2 and Cl2? Do you think so? Do you think hydrochloric acid is going to have the properties similar to H2 and Cl2? No, Mayank. No. When they chemically react and they give you a compound, that compound has its own properties, physical and chemical. Nothing doing with the reactants. Entirely different. I give you one example. This is a very important concept. The chemical and physical properties of this compound will be entirely different from the chemical and physical properties of H2 and Cl2 because the chemical composition is changing. Now it's an entirely different compound. Like for example, H2 gas, very combustible, very combustible. O2 gas, a good supporter of combustion. Without oxygen, there is no combustion. You know that, right? What's the product? Is this water combustible? Is water combustible, children? No. Is water a supporter of combustion? You are using water to extinguish fire, right? So water is going to extinguish fire. It's not a supporter of combustion at all. So can I say the chemical properties of water are entirely different from the chemical properties of hydrogen gas and oxygen gas? Can I say that? Yes, so remember that. So this question can be there. It's not a mixture, okay? You are not, it's a chemical reaction, it's a chemical change. It's not a kind of that you are mixing gases and they are not making any compound. When you mix gases, like if I mix hydrogen gas with oxygen gas and if there is no reaction, then I can say, yes, the mixture is written. So please write on this, the mixture. Mixture means no chemical reaction. In the mixture, whatever components are there, they are going to retain the properties. Physical as well as chemical. Properties of components. Okay. So please write on this. Amodita, you're there? Ready for this question? Okay, make the formula. The way we did that ClF5. Exactly in the same way. You know the formula of nitrogen gas? N2. This is one volume. How much volume is this? How much volume is this? 2, 2. It's given. This is the product. Make. So 1 volume of N2 reacting with 3 volumes of H2. So what should be the coefficient for H2? This coefficient is 1. What should be the coefficient for H2? Yes, 3. Giving you 2 volumes of NXHY. The one which is more in number, like hydrogen is more in number, take it on the second element. The one which is less in front. Now Amodita has already answered it. What is X here? 2 is written in front, right? So X is 1. Do you agree with that? Because 2 is written in front, so X is 1. And how many? There are 2 nitrogens. There are 6 hydrogens. So what should be Y? Y should be 3. So can you see the coefficient is the volume? This coefficient, 1 volume. This coefficient, 3 volumes. This coefficient, 2 volumes. 2 volumes is written here. Is given to us. Meg? Okay, moving on. These are different questions. Now we are going to work out, now we are learning the mole concept, the percent composition, and how to work out the empirical and the molecular formulas, empirical and molecular. Now we are going to work out different types of questions based on the same thing, directly, indirectly. So see this question. These are lab-based questions also. Many salts, they exist as their hydrates, like copper sulfate. This one is anhydrous. Anhydrous means no water. No water. And you know this copper sulfate is amorphous. Amorphous means like a fine powder. Like a powder. And it is colorless, no color. Colorless, white in color. So what is the meaning of anhydrous? No water, right? And what is the meaning of amorphous? New language. We are learning language also. What's the meaning of amorphous? Fine powder. Yes. Slippery powder. Fine. and is colorless. No, colorless means white in color. White. But when you put this copper sulfate, which is amorphous, you put it in a container and leave it outside in the atmosphere. And if the atmosphere has moisture, moisture means water. So when it is left open in the moisture, moisture means there is plenty of moisture in the atmosphere in the lab, you put it open, it will become CuSO4 5H2O. The formula changes. And this number is fixed. With 1 mole of copper sulfate, 1 mole, there are 5 moles of water. This is fixed composition. And this one is called as hydrated. Hydrated salt. We have plenty of hydrated salts. Sodium carbonate, which is also used as washing soda. When I say sodium carbonate, anhydrous, but you leave it in the presence of moisture, it will become 10H2O. Now this is also hydrated salt. This copper sulfate, when it becomes hydrated, what are the changes taking place? Like I said, this is amorphous, but you know this copper sulfate is crystalline. Crystalline. Crystalline means when you pick up this salt and when you try to feel it, you can feel sharp edges. It's not a fine powder. You can feel edges. It has a well-defined structure. The crystalline form means very well defined. We are going to do this in unit 3 when we are going to learn about solids. Like this, these are the edges, just like your salt. You take salt, put it in your hand, rub your hand. You can feel sharp edges. But you take talcum powder, the powder which is there on the dressing table, you put it in your palm, rub it, no edges. It's very smooth, fine. You're understanding this? So the crystalline forms, they have sharp edges. They have very systematic, very regular arrangement. And you know what is the color of this hydrated copper sulfate? Blue. It is blue in color. No, Mayank, we are not making a solution. This is solid. Mayank, this one is solid. We are not making a solution. Right? Yes, this can happen when you add excess of water. Are you adding excess of water? No. You are just leaving this amorphous solid, this one, in the air. You're not adding water. It's taking moisture from the air. And that moisture is converting this copper sulfate to this crystalline form. So you're not adding water from your side, right? You're not making a solution. It's in the solid form. Are we clear about it? Amodita. Amodita, are you there? You've understood this? So what is the meaning of anhydrous? What is the meaning of anhydrous? No water. And what is the meaning of hydrated? What is the meaning of hydrous or hydrated? Has water. Yes, very good. Which one is crystalline? The one with water or the one without water? No, Mayank, with water. The crystalline form is with water. I was writing here. See the crystalline with water. The crystalline form is with water. And the amorphous form is without water. And it is applicable on all salts. All salts without water, they are amorphous. They don't have a systematic kind of latex or with sharp edges, nothing like that. And with water, they are crystalline. So which one has sharp edges? The crystalline form or the amorphous form? Which one? Yes. And which one is fine powder? The amorphous. Yes. I'm giving you practice on the language also. Crystalline, amorphous will come again in unit 2 and 3. Okay. So please practice it. Ready for this question? Do you know the formula of magnesium chloride? Give me the formula of magnesium chloride, children. Check the periodic table. What's the formula of magnesium chloride? MgCl2. And this is the anhydrous form. Is going to absorb. Please understand my language. This is solid. I'm not making solution. I'm saying the anhydrous form is going to absorb water vapors and is getting converted into MgCl2 XH2O. I don't know X. And this is the crystalline form. And hydrated. This is hydrous, hydrated. The first one is anhydrous. They say is analyzed and found to contain 53.18% water. How many water molecules are found in this formula? So what I have to calculate? X means in one molecule, how many water molecules are there in one? Or you can say in 1 mole of MgCl2, there are X moles of water. Can I say that? My aim is to calculate X. What I know? Yes, what I know, Amodita? I know this MgCl2 XH2O, that formula. What else is given to me? If C%, if MgCl2 XH2O is 100 grams, I'm going to assume 100 grams, then 53.18 gram is water. This is what I know. This is what is given to me. Is this information sufficient for me to know X? Yes, it's sufficient. How? Okay. Do you know the grams of MgCl2 in the sample? Yes, please. Give me the grams of MgCl2 in the sample and convert these grams of MgCl2 to moles of MgCl2. Can we do that from this information? Yes, Amodita. So the grams of MgCl2 is 46.82 grams of MgCl2. Now plug in the ratio to get the moles. Mayank, you are with me? MgCl2 divided by divided by 95.21. Okay. And I think Amodita is giving me the moles of MgCl2 is 0.4917 moles of MgCl2. Very good. Do I know moles of water in this sample, 100 grams? Do I know? Like with these moles of MgCl2, how many moles of water? I know the grams of water. So convert your 53.18 grams of water to moles of water. How much you are getting? When we do so, Amodita is telling me, yes, very good, 2.95 moles of water. Now I can take this ratio and I can put it equal to this ratio to know X. So I can say 0.417. I'm writing here, children. So I want to know X. Okay, let's take X in the numerator so that calculation will be easy. So X moles of H2O divided by 1 mole of NgCl2 is equal to 2.95 moles of H2O divided by 0.417 moles of MgCl2. Can you solve this ratio? Get the value of X. Yes, children, what is X? 7.07. So you can take it as 7 because this is a number. X is a number, full number, whole number. So take it as 7. So what's the formula of the hydrated magnesium chloride? What's the formula of magnesium chloride hydrated? MgCl2 7H2O. This is fixed. You check it on the internet. Just write on hydrated magnesium chloride. You'll get this formula. It's fixed. The way I was talking about copper sulfate. So it's also fixed like this. So these questions can be there as lab questions. Amodita, is it clear? Is this method of taking ratio clear? It's mathematics. Any confusion here? Okay, good. So I'm taking you now on the other question. Again, hydrate means hydrated salt. So let's do this question. Can you give me the formula of copper 2 chloride? Here the information is given in a different manner. Yes, very good. CuCl2. Hydrate. I don't know X here. Right? This is the formula of the hydrate. Agreed? CuCl2 XH2. Heated to drive off water. What does it mean? If I heat this compound, what will come off? Yes, remove water. It becomes anhydrous. Water is out. Right? Like this. Okay, this is solid. This is going on as gas, vapors. This is solid. Which one is crystalline? Which one has sharp edges, crystalline form? With water. Very good. Okay, now they started with 34.1 gram of this and they are left with 26.9 grams of this. Can you work out the mass of water which was driven off? Can you work out this mass of water using the law of conservation of mass? Yes. So it means the grams of CuCl2 is given to me. I know it from the question. And the grams of H2O is also given to me, which I think both of you calculated as 7.2 grams. So don't you think now the question is very simple? Convert these grams of CuCl2 to moles of CuCl2. Same with this water, moles of water. Now, from this formula, you know that X moles of water are there in 1 mole of CuCl2. You know this ratio from this formula. You put it equal to this ratio. So can you calculate these values and give me the values? Calculate the moles of CuCl2, moles of water. Then we are going to plug in here. Yes. Mm-hmm. Mayank is saying 0.0536 moles of CuCl2. And Amodita is giving me 0.399 moles of water. Plug in here and get the value of X. So I'm just assuming that both of you have given me the right calculation. Oh, Mayank is wrong. Can you check it again, Mayank? Amodita? Oh, this number is wrong. Yeah, this number is wrong. It's 0.2. Take care. You're working with 3 significant figures. Go for 3 sig fig, right? So in the free response, we have to take care of the sig fig. So 0.399, water is in the numerator, moles of H2O over 0.200 moles of CuCl2. Get the value of X. What is X here? Take this number on the other side and get the X. Yes, Amodita, what is X? 1.9. Oh no. I'm getting 1.995, which I can approximate it as 2. So the formula is CuCl2 2H2O. Can we check our answer on the internet? Mayank, can you type on the internet the hydrated formula of copper 2 chloride? And give me what they are writing. Are they writing 2 here? Because these numbers are fixed. Amrita, check your calculations. Yes, Mayank. Do you think it is correct? I know it is correct, but can you check it on the internet? By the time Amodita, check your calculations. Yes, Amodita, are you done with the calculation? You have seen your error? Okay, good. Moving on. Same question, water of hydration. So hydrated salt and hydrous salt. Get the formula. Exactly similar type of question. But information given here is in a different form. Read the question carefully and tell me how to do this question. So you started with the hydrated form, Na2CO3 XH2O. What are you doing with it? You are heating it. This is the symbol of heat. So what is formed? Anhydrous Na2CO3 solid. Where is water? Evaporated as gas. With how much mass you have started? 90.00 grams. How many moles of this is formed? 0.314. This is not grams, this is moles. Can you use this information to know the grams of water? This one is more simpler question. They have already given you moles of Na2CO3. Can you convert these moles of Na2CO3 into grams of Na2CO3? And then convert this grams of Na2CO3 into grams of water? Then convert those grams of water into moles of water. Can we do that? Yes. How? Moles is given 0.314 moles of Na2CO3. I'll take this ratio. Molar mass 105.99 grams over 1 mole of Na2CO3. This will give me grams of Na2CO3. How much is this? Bank? Amodita, how much is this? You're doing calculations, Amodita? 33.28 grams of Na2CO3. Can we convert this grams of Na2CO3 to grams of water? The total mass is given to us. So the grams of water are, work out the grams of water. 56.72 grams of water. Can I convert these grams of water to moles of water? It is 3.148 moles of water. 4 significant figures, Mayank. We are working with 4. My first number which is given to me here, oh, this one is 3. Okay, fine. You can work with 3 also. Okay. So significant figures in these questions, this type of questions are not important because finally you are working out a number. Okay, so you are working out a whole number. So significant figures are not important, but try to be more accurate. Now, what should I do? From the formula, I know that X moles of water are needed for 1 mole of Na2CO3. Now I know the moles of water in the given moles of Na2CO3. Plug in this ratio here and get the value of X. Get the value of X. Is it 3.7? It should be a complete number. I'm getting 10. Amodita, what are you doing, dear? Are you taking ratio in the wrong way? Are you taking moles of Na2CO3 in the numerator? Okay, good. So what's the formula, Mayank? Type the formula and check it on the internet. Hydrated form of sodium carbonate. I'm asking you to check on the internet because I want you to understand that they have fixed composition. Na2CO3 10H2O. Put a dot here. This is the hydrated form. These number 10, 7, 2, we calculated 7 in magnesium chloride. We calculated 2 in copper 2 chloride. And here we have calculated 10. Yes, very good. Amodita, do calculations carefully. Ready for next? Again, It's a hydrated question. But this time they have given you the formula of the hydrate. Formula of the hydrate is given. And they are asking the mass of sulfur in the original mixture, in this mixture, in 100 grams. Mass of the sulfur. So what should I do to know the mass of the sulfur? Remember, you have done the percent composition, percent by mass. I'm not going to make this question very complicated. So the information is given to me in a very complicated form, but we know that percent by mass, that composition is fixed. So what is percent by mass of sulfur here? It is the mass of sulfur. If you remember the equation, we did this complete topic if you remember. It is the number of atoms of sulfur n times atomic mass of sulfur divided by molar mass of Na2 S2O3. They are asking me to calculate the percent mass of the 100 grams, not of this, of this. So I will take 7H2 also. Understand that. Because they are asking the mass of sulfur in the original 100 gram mixture multiplied by 100%. You're understanding here? So don't work with this, work with this. So how many atoms of sulfur are there? 2. What's the atomic mass of sulfur? Look at the periodic table. Yes, who is going to give me the atomic mass? 32.06 units, grams per mole. In the denominator, now work out the molar mass of this. To avoid the error, Amodita and Mayank, if you don't want to do errors, then always make a habit of writing this. 2 sodiums, 2 sulfur, 3 oxygens, 7, we know water, right? 18.02. So I'm taking it all together. Otherwise, 14 hydrogen, 1 oxygen. So calculate. Do it like this, step by step, to minimize errors. Okay. As I said, we are learning new things. Whenever you are learning new things, slow down. Go very slow. Keep thinking, do slowly. Then once you are expert, you can go very fast. So what is the molar mass of this compound? Okay. Is it 158? Amodita, check. Because we don't want to do error here. If we do error here, then all my answer will be wrong. So I'm checking answer given by Amodita. You are not doing. So Mayank, I think your answer is wrong. Did you include water? This? Did you include this? Amodita, I'm asking you to check his molar mass. The molar mass given by Mayank, 158.1, which is wrong because I'm getting something else. I'm getting 284. And that's the reason I'm asking you to write step by step. Whenever there is a complicated formula with so many numbers, do it like this. So Mayank, I told you to include water because they're asking in this sample, in this 100 gram, they're asking in 100 grams. How much percent? So you have to take the molar mass of the hydrated form. So are you getting this now? 284.14 units are grams per mole multiplied by 100%. Now this is cancelled. Work out the percent of sulfur. This is giving you the percent of sulfur in the given sample. This hydrated sample, not this. This will have a different percent composition. This has a different percent composition. Formulas are different. Molar masses are different. How much we are getting? Okay, is it? Amotita, your answers are not coming at all. So it is 22.7%. Yeah, you're right. Of sulfur. Can you tell me how many grams of sulfur is there in this sample? Grams of sulfur. Same, yes. 22.7 grams. Good. Is this question clear? Moving on. Let's do this one. These are very important questions. Percent purity. Purity means when we take a sample. So generally the sample is not made up of only that compound. There are some other compounds are also there. So most of the things in the nature are in the form of mixtures. So there is always some kind of impurities in the sample. Do you know the formula of copper 2 oxide, children? What's the formula of copper 2 oxide? Yes, CuO. Very good, Amodita. Now they have taken 5.0 grams of the sample. Is this sample pure or impure? Read the question and tell me, is it pure or impure? Is this sample has some kind of contaminant in it, or it's just a pure sample? It's contaminated. The sample is contaminated. No, no, no. Mayank, no. Amodita, no. The sample is this is the uh, chemical in the sample with some other contamination. It's not copper. They're not talking about copper. In this 5.0 grams of sample of this compound, there is some inert contaminant. They are not saying oxygen is contaminant. Oxygen is the part, right? So you can say this is not pure. Pure. Now what is given to you? 3 grams of copper. That is pure. They say after taking this 5 grams of sample, after doing all the chemical analysis, they found that this sample has 3.0 grams of pure copper in it. And that pure copper is coming from here. So it means I have 3 grams of copper. Can I convert this grams of copper to moles of copper? Can I convert moles of copper to moles of CuO? Can I convert the moles of CuO to grams of CuO? And this is the mass of the pure CuO in the given 5.0 gram. 5.0 gram is not pure. So whatever pure is there, that is going to be here. This is pure. So in 5.0, this much grams of copper oxide is pure. And then you have to work out the percent purity of the sample. Formula for the percent purity is pure CuO in grams over mass of sample, which is 5.0 grams, multiplied by 100%. So we are doing it. Okay, let's start. I think Mayank has already started doing it. So I'm going to convert 3.0 grams of copper into moles of copper, 1 mole of Cu divided by 63 point something. What's the atomic mass of copper? You have the periodic table in front of you? Yeah, 63.55 grams of Cu. I'm not stopping here because don't calculate for every level. Just do the dimensional, reach up to here. Then in 1 mole of CuO, how many moles of copper are there? 1:1. So I can say 1 mole of CuO over 1 mole of copper. Can you see this cancelled? Then what is the molar mass of CuO? 63.55 plus 16, 79.55. So I'll take that in the numerator, grams of CuO divided by 1 mole of Cu. Do the question in dimensional. It's going to help you a lot. You need not to calculate every time. Now you can plug in one go and get the grams of your CuO. And that is pure. I'm getting 3.7. I'll take only two significant figures, 3.0 grams, so 3.8. 3.8 grams of Cu. Amodita, is it correct? 3.8 grams. So the percent composition, now I'm going to use this equation. So the percent composition is, percent purity of the sample is 3.8 divided by 5.0 multiplied by 100. And Amodita is saying 76%. I'm getting 75.10, so I'm getting 75%. Amodita, can you check your calculations? Okay, if you don't do approximation, then I think Amodita is right. If we do approximation here only in the, we keep going, whatever we are getting here, if the way Mayank is writing, it is 3.71. I think this is the answer. Just check your calculation once more. If I write 75% and Amodita is saying 76%, she will get full marks. The reason? Because this number is estimated. Remember we discussed like there is a video on the measurements, uncertainty in measurement. Watch that video, do the quiz. So this number is estimated. So we can have error in the estimated digit. So Amodita will get full marks. I will also get full marks. Mayank, you're getting it? Okay. Ready for this? Yes, slightly. Again, complicated question, more of the mathematics. 75% X in XY. So in XY, when the ratio is 1:1, how much is X? 75. How much is Y? How much is Y? 25. You can assume the total is 100 grams, right? So the grams of X are 75 and the grams of Y are 25. In XY2, if the ratio is 1:2, if I take 75 grams of X, How much is Y2 then? Y is 25, so Y2 means 50 grams of Y. So what is the mass of XY2? Mass of XY2 will be the sum of these two, which is 125 grams. So what's the percent of X in this 125? It is the mass of X divided by total mass of the sample, 125. Mass of X divided by 125 multiplied by 100. Yes, and the answer is 75 over 125 over 100. You people are smarter than me doing calculation very fast. See, this is just mathematics, right? So that's the end of your chemical composition, hydrates formula. You can do the quiz on it. And in the next class, I'll start the next topic of Unit 1. See you in the next class. If you have any questions, you can stay back.